This is 3.6 in your textbook. We're adding and subtracting polynomials. Who likes to read? Anybody? Nobody likes to read? Thank you, Matthew, in the front here.
Have you ever wondered about who writes textbooks like this one? When did they write these books? How do they get paid? Experienced mathematics teachers write most math textbooks. They usually write when they are not teaching. They are paid in different ways, depending on their contracts. A fixed amount or flat rate, a royalty, which depends on the number of books they sold, a combination of fixed amount plus royalty. Why do you think they are paid in these ways?
Anybody? Yeah, Steven.
Depending on how much they sell or how well they do.
Yeah, good. So why do you think a publisher might pay them a royalty as opposed to a fixed amount? Yeah.
Well, depending on the sales of the book depends on how much money they'll get. So even if the book does really well, then we'll only get a small amount of that profit.
Right. So basically, the publisher wants to ensure that the book sells before they commit to paying the author. Okay. All right. Well, hopefully, we're going to find out why that's relevant to this particular example, adding polynomials. The first says simplify each expression. So this is what we started to do yesterday when we said gather like terms. When we have brackets, we know from BEDMAS that we need to operate in the brackets first. Can anybody tell me, or actually I'll ask Sebastian in particular, Sebastian, can we do anything in these brackets to simplify?
Well, like, would you have to, so if you were going to simplify, would you have to stay in the brackets and simplify within the brackets? Or would you be able to simplify between brackets?
Right, so that's my question. Can you do anything in this bracket here?
No.
No, there's nothing we can do here, right? 4x plus 3, those are both unlike terms, so we can't do anything with them. So really, we can just say that this is in the brackets. I can't do anything with those. I'm going to take the brackets off, okay? And I'm going to work with this other term here, which is also in brackets, which I also can't do anything with. So I'm just going to add that term. And now I'm going to work with this equation here, okay? The reason I was able to just take those brackets off is because there's no number here. If there was a number here, I would have to first multiply each term by that number, okay? There is a number there, actually. You can't see it, but what is that number? Yeah, Henry.
Pardon me, would Nathan Memorno please come to the office? Nathan Memorno?
Yeah, it's a little imaginary 1. So even though there's a 1 there, we know everything multiplied by 1 is still itself. So we don't bother going through the exercise of multiplying each one of these terms in the brackets by 1. Okay, so we can just remove those brackets when it's adding. Okay, if there was a negative sign here, which we're going to see hopefully soon, we're going to see that we would have to distribute that negative sign before getting rid of the brackets. Okay, once we have it in this form, Sal, what can we do?
We can just add variables, so make it 11x. You add the center of the 4.
Yep.
And then you put plus, and then you add the 3 and the 2, so you do 11x plus 5.
Excellent. Okay, next one over here. Okay, Nicholas. Can we do anything in the bracket here?
No.
No, we can't, because why not?
Because 0.5v squared has an exponent of 2.
Right, so it's not a common term. Okay, we can't do anything in the brackets, so we're going to get rid of those brackets. Again, we're allowed to just get rid of them because there's nothing in front of them. So here, plus negative 2.4. I could write that like that. Keep the negative in a bracket, and then negative 3v. Or I can change this plus negative to just a negative. Okay? That's negative 2.4. Okay? Any questions there what I did? If you have something like this, plus negative 3, so 4 plus negative 3. This is the same thing as 4 minus 3. Right? Okay, so if you see something like that, a plus negative, you can get rid of that plus. All right, so now we have this expression here. Tyler?
So we have 2p subtract 2, so you can't do anything in that bracket. And then you have 4p subtract 7, and you can't do anything in that bracket.
Oh, you're over here in B. Sorry, I was working on C for some reason, but okay. Yeah, you're in B. So keep going.
So then we're gonna get 2p, and we're gonna add 4p to 2p, and
Yeah.
that'll give you 6p. And then you're gonna get negative 2 subtraction 7,
Yep.
and that's going to get you negative 9.
Excellent.
So the answer is 6p plus negative 9.
Yeah, or 6p minus 9.
Okay.
Okay, so when we have plus negative, we just put minus. Okay, any questions there? Finally, this last one, Sebastian. Tough to see. Maybe just go from here. From there, okay? Over to here.
Okay, so because now you've taken away the brackets, you could
Yep.
just do 0.5 add negative 2.4,
Okay, so what's that?
negative 2.9, no,
No?
1.9,
Good. Negative 1.9, good. Negative 1.9 what?
squared,
V squared.
oh, b squared.
Yep.
And then you would add positive 2 and negative 3 point.
Which is?
It would be negative 1, b.
Okay. Am I going to write the 1?
No, just
Excellent. Any questions? All right. Let's check those answers. They're here. 6p minus 9, 11x plus 5, and negative 1.9 v squared minus v. All right. Next, we're looking at opposite polynomials. State the opposite of each expression. So opposite in math, when we refer to opposite, we're referring to the sign. Okay, so max A. 7, what's the opposite?
negative 7.
Good. Negative 2x, what's the opposite?
2x.
Right. 4x plus 1, Tim.
4x plus 1. Negative 4 minus negative 4 plus 1.
Nope. The opposite of 4x plus 1 would be negative 4x minus 1. No, you didn't. Tyler?
Oh,
So why don't we change the 1 in that expression to a negative 1?
Yeah.
Why do we?
No, why don't we? So why wouldn't it be negative 4x subtract negative 1?
It is.
Negative, if you subtract the negative, it's just
It is.
plus negative.
Oh,
Isn't that what I just wrote?
oh, okay.
That's what I just wrote. Negative 4x minus 1.
No, but he's saying, why don't you do negative 4x minus negative 1, but it's just like a positive, it's just the same.
Yeah, so it's the same thing.
No. Negative 1 is positive 1. So this is not the same as this.
No, that's the same as the one up top, that's why you're supposed to flip it.
Okay.
Anyway,
Don't really get that. Alvin, next one. D.
Oh,
We're just switching the signs, right? The opposite of 5y minus 2?
negative 5y plus 2.
Excellent. Yeah, we're just switching the signs. Luca, second row.
Is it, do I do?
Switch the signs. Right? The opposite. You're switching the signs. So this is positive x squared. It's going to become,
Negative x squared
okay, next one.
plus negative 3x.
No, not plus negative 3. That'll be negative 3 again. Just plus 3x, right?
Plus 3x.
And then,
And then negative 7.
good. We're just switching the signs. The opposite, right? You just change the sign. That's it. All right. Yeah, the reason we did that is because now we're looking at subtracting polynomials, and when we subtract polynomials, this negative sign here needs to be distributed to the first and second term. So it actually multiplies and changes the sign of both of these terms in the brackets. Okay? We're going to cover this in 3.7. This is called the distributive property, and we're going to do it with when there's actually a number here, but this is still a number. It's negative 1, right? And that negative 1 needs to be multiplied by both the 7y and the negative 4. Okay? So this equation then becomes 3y plus 5. Now negative 1 times positive 7 is negative 7y. Negative 1 times negative 4 is positive 4. Okay, so that negative sign in front of the brackets is going to switch the sign of each term inside the brackets. Any questions about that? No? Okay, Hugo, next one.
Okay, so for B,
Yep,
you can't do anything in the first bracket.
Excellent.
In the second.
good.
So then you break it down and
Wait, sorry, what'd you say about the second?
you can't do anything in the second bracket.
Okay, you can't do anything in it, but in order to get rid of the brackets, what do we got to do?
We have to switch the sign.
Excellent, good.
So
So,
it's
yep, go ahead.
positive a squared
Yep,
and then negative 2a, positive 5.
okay, I agree with the positive 5. Why negative 2a?
Oh, sorry, positive 2a.
Right,
And then from there, it's a squared plus a squared, which is 2a squared.
excellent,
And then you cross out the 2a and the 2a,
good.
and then it's 1 plus 6. 1 plus 5 equals 6.
So plus 6,
Yeah,
right?
plus 6.
Okay, and this one I didn't finish off. 3y and negative 7y is negative 4y, and 5 and 4 is plus 9. Any questions there? All right. Example 4. Apply an algebraic model to solve a problem. So it says 4 authors team up to write a textbook. The publisher negotiates the following contracts with them. So here are the authors. This is the fixed rate they get, so the amount they're paid, and then they get a royalty, so the amount of dollars per n books sold. So if there's 1 book sold, Jamal gets $2, Vera gets $1, and Fleming gets $3. If there's 2 books sold, again, 2 is going to be substituted for n, and these multiply. It says write a simplified expression for the total payout to the authors. Okay, well, Lita's payment, we know, is just going to be $2,000. Jamal's payment is going to be $1,000 plus 2 times however many books are sold. And Vera's payment, $1,500 plus however many books are sold, $1 for every book. And finally, Fleming gets 3n. Okay, so if we were to write this out, we want to say the total amount that's being paid out. We would just add all these up, right? Plus, plus, plus. Okay, so we could rewrite that like this, like so, down here. 2,000 plus 1,000 plus 2n plus 1,500 plus n plus 3n. Okay, now we can just get rid of the brackets because there's only positive 1 in front of them. Right, so our next step is just the brackets gone. Then we gather like terms, and we get 4,500 plus 6n. So the publisher will pay 4,500 plus 6n to the authors, where n is the number of books sold. Any questions about that example? Okay, B. Determine the total amount paid to the authors for 1,200 books. So we're going to take 1,200 and do what with it, Alex?
You're gonna do 4,500, which is just how much the fixed rate, I guess. And you do, instead of putting n there, you put 1,200.
Excellent.
That's how many books were sold.
Perfect. You're going to substitute in that 1,200 for the number of books sold. So that's what we do over here. And we get 11,700. Any questions? All right. So the key concepts to add polynomials, we remove brackets and collect like terms when we're adding, because again, when we're adding, we're just multiplying by positive 1, which is the same. So we can just get rid of the brackets. To subtract a polynomial, you add the opposite polynomial. You can think of it that way, or you can think of it, you know, if there's a negative sign in front of the brackets, you got to switch the signs and get rid of the brackets. Okay, I'd like to think of it that way instead of adding opposite is a little confusing. Any questions? All right.